3D graphics. That's what we're going to be talking about today. So here's a box flying around and rotating in space. This is just a built-in demo to TempleOS. Here's the box demo. So we're going to use this as a basis, but we're going to make a tetrahedron instead of a box. So this box is in the demo/graphics directory, and it's box.hc.z. So I just wanted to start out by showing you the box, but I'll exit this. And show you how to start from scratch. So let's kill that virtual machine. I'm using QEMU now. I had a little bit better luck with this than VMware or VirtualBox. So this is what I'm using on Windows now. So I'm going to start my virtual machine. Select the C drive. I wish I could find a way how to skip that, but I just have to hit 1 to select the C drive every time. At least I'm actually installed. Let's Control-F to go full screen. At least I'm actually installed instead of running from the installation CD every time. So, I'm in my home directory here. Let's say no to the tour. So the first thing is making a new directory. So the graphics is in the demo directory, but I'm going to copy this to my home directory. So first of all, excuse my slow typing. I'm really not used to the QWERTY keyboard. Yep, that's wrong. It's demo, not demit. So there's the demo graphics directory, there's the box file that we'd like to use as a template. So I'm going to copy that to my home directory. You can select and then shift arrow right to select some text. So I'm going to copy that path, and then I'm going to copy the file. The thing that was messing me up last time is that shell commands are wholly C. The shell language and the programming language are one and the same. It's not like Linux where there's bash for shell scripting and C for programming. Here there's just wholly C, so all of the shell commands have a C-like syntax where it's the name of the command and then parentheses for arguments and then a semicolon. The semicolon at the end of the line is very important, so you can't leave that off like bash because this is a wholly C command. So I'm going to paste that argument in there, and then box.hc.z. Everything is case sensitive, by the way. Actually, I need to make a directory first. So I'm in home, and it's not mkdir, it's dir mk. Let's call it YouTube. Okay, I made that directory. Now I can copy into the directory that I just made. I'm just navigating with arrow keys, so I actually ran this command, but I didn't run this command yet. .hc. File types are important, so .hc is a wholly C program, and it has to be uppercase HC. And enter that. So now I can dir my home directory. I have the YouTube directory. I can CD to YouTube by just clicking on it, left clicking. And now I have tet.hc in my YouTube directory, so I can edit this by left clicking on it. There we go. I'm editing this. First thing I'm gonna do is I want some indentation because I don't like the window text being right next to my text. It's kind of hard to read. So Control I at the top to indent everything. And now I have a little bit of space for readability. Also gonna enlarge this window so I can do that by clicking and dragging. If I actually click on the border, there we go. It's hard to resize the window as opposed to move the window. You have to click just right. Nope. Okay. Better at resizing from the right than resizing from the left. Okay. Let's say that's good enough for resizing. So, this is the demo that I showed you at the very beginning of this video. I'll hit F5 to run it. There's a box. Escape to exit, Shift escape again to exit again, and now I'm back in the program. So, maybe I should just go full screen. I'd rather not go full screen because I'd like to show you some things in the other half of the window too. Don't know what I just accidentally ran there, but let's CD again. Okay, first thing is I'm not doing boxes, I'm doing tetrahedrons. So let's call it tet instead of box. And this is how you run the main program. There is no main in Holy C, it's more like Python. So everything that's outside of all functions just runs as if it's main. So tet is running as the main function. And then tet draws a tetrahedron. Let's call this draw tet instead of draw it. And I have to rename it here as well. Hopefully that still runs. I'll show you how to run it from this window. So dir to show what's in the directory, and then if I right click on this, it brings up this menu, which you can navigate with the arrow keys, and you run it by including, which does just-in-time compilation. So to select that, I just hit space, and there's my square program. Let's resize this window too. There we go. Now we can see almost. Yeah, now we can see the whole box without the box going outside of the window. So escape. And there we go. Okay, so this is the box. What do we have here? We have 12 gr line 3 commands because a box has 12 edges, right? That's 4 in each direction, and there are 3 directions, so 4 times 3 is 12. That's why there are 12 lines to make a box. Let's comment that out. You can use C-style comments or C++ comments. The C-style comments are a little bit easier for commenting whole blocks, so that's what I'll do. And then let's go ahead and make a tetrahedron instead of a box. So there are 12 lines here, and there are 24 coordinates, right? Because there are 2 points for each line, and there are 12 lines, so 2 times 12 is 24 sets of XYZ coordinates here. That's really redundant because you have 24 points, but there are only 8 points in a cube. So instead of typing out the point coordinates every time, I'm going to save my points as 3D vectors. So let's do F64 for a 64-bit floating point number. And let's call our points A, B, C, and D for the 4 corners of the tetrahedron. So A is 3D, the 3 means it's 3D. separate these by commas. So B, C, and D. And now I have to define the coordinates for each point. So A is going to be all in the first octant, so all positive numbers. I have R. Yeah, let's define a radius for the tetrahedron. And this is probably going to give a compile time error. Let's save that. Control S is saved, so I just hit Control S in this window and that saves. And then I'm going to run it from here like we did before. So right click, space. Yeah, compiler parse error at R. A equals R. So it does not like this line. I found some guides on the internet that says this is how you declare arrays in Holy C. I don't think so. That's not how you declare arrays in Holy C. So this syntax doesn't work for me. If you know a little bit less verbose way to set array components, let me know, because the things that I see online don't work for me. So I'm just going to have to assign them one at a time. Okay, that should be my first point, so I think this should compile. Save. Compile. Oh, I crashed the operating system. So, that's good. I'll show you how to get out of that. So, Control-Alt-F to get out full screen. I'll kill this from the command line, and then start up the virtual machine again. The TempleOS is very easy to crash. It's a ring 0 only operating system, as opposed to Linux where there are like 7 rings or something, so that user programs can't crash the kernel. But here in TempleOS, the user programs have access to the exact same memory space as the operating system kernel, so it's really easy to accidentally modify kernel memory and crash the whole operating system. Obviously, this should be 2 instead of 3, because these are 0-based arrays, A0, A1, A2, as opposed to A1, A2, A3, like you would have in MATLAB or Fortran. So I'm pretty sure that was the problem. Save. Let's compile that. And there we go. That runs without crashing. I have a blank screen because I commented out the box graphics. So, of course, I have no graphics now since it's not actually drawing anything. We're going to copy and paste this. So I went to the end of the line, and then to select, Shift, arrow key up, and then I can Control-C, Control-V to copy paste. And now I just want to define point B. And this is going to have different coordinates than point A, so the X and Y are going to be at -R instead of +R, and then Z is still going to be positive. Now that we have 2 points, we can make a line. So GR line 3 is what Terry does for the box. So let's do the same thing, but with our tetrahedron coordinates. So we're going to have A, X, Y, and Z. And then B, X, Y, and Z. Close parentheses, semicolon at the end of the line. There we go. So I think that should make a line. Let's test it. Here we go. It's a line flying around and rotating in space. Now we just have to do the other 5 lines of a tetrahedron. Escape, shift escape. Whoa, what happened there? I think I closed the window. That's fine. I really only need 1 window anyway. Alright, now you don't have to worry about the text spilling off the end of the screen. If you want to turn on word wrap, by the way, Windows key to get to the menu at the top, and then while you're holding the Windows key, use the arrow keys to navigate from File to Edit to Insert, and then go down to word wrap on. And it didn't work. So, never mind. That worked for me once before. I'm not sure what I did wrong. Maybe I'm in the wrong window or something. But it doesn't really matter. Let's go ahead and make the other 6 lines. So, copy that. 3, 4, 5, 6. These are all A, B. So, I need to define points C and D of the tetrahedron. So, I'll copy and paste that as well. It's going to be C, D, C, nope. The editor is not too bad to navigate. It's a modeless editor, so you use the arrow keys to navigate, and then you just start typing to insert. It's not like Vim, where there are separate navigation and insertion modes. There's just one mode in this editor. So it's hard to edit fast, but it's not difficult like Vim. So in case you don't know the points of a regular tetrahedron, the first point is going to be all positive, and then the other 3 points are going to have 2 negative coordinates and a positive coordinate. So we just need to do the other permutations there. Doesn't really matter what order they're in, but you have to get 4 unique points. So now A, B, C, and D all have different coordinates. Actually, I don't want to do it this way. I want to make a function. Because you notice I have A, B, B, B. That's a lot of typing. I'd rather not do all that typing. Didn't mean to exit there. So delete that. Nope. Cut. Cut is a way to delete a big selection, so Control X. Anyway, I'm going to make this into a function, so copy that. And we're going to make a void function. So void is U0, like a 0-bit unsigned integer, but it's 0 bits, so it's void. But Holy C doesn't have void, it has U0, which is like void, so that's how you do it. Instead of gr line 3, I'm going to name this my line. I don't really like mixed case, so I'll just do it all lowercase. And this is going to take a CDC pointer, just like gr line 3. Did not mean to do that. CDC pointer DC, and it's going to take a point A and a point B. And what are these? These are 64-bit float pointers. Because they're arrays, they're not just scalars. I'm doing this function with arrays. And paste. Okay. So is that correct? I hope so. Now let's call my line instead of directly calling gr line 3. Hopefully this runs without crashing. Yeah, alright, so we still have a line. Now I just need to do that 5 more times. So 1, 2, 3, 4, 5, 6. 6 times total. So there's a line between every pair of unique points in the tetrahedron. So we have line AB, AC, AD, and then BC, BD. Again, it doesn't really matter what order you do these in as long as you do every unique one. And I believe that's every pair of the 4 points. So that's it. That's how you make a tetrahedron in the built-in graphics of TempleOS. Again, this is all built in. There's no OpenGL library. It's just right there, built into the operating system. It's super easy. That's how you do a tetrahedron. That's it for today. I'll catch you next time.